Direct cycles in a 2D grid. Given a 2D array of characters grid of size m cross n, you need to find if there's a cycle consisting of the same value in grid. A cycle is a path of length 4 or more in the grid that starts and ends at the same cell. From a given cell, you can move to one or the cells adjacent to it in one or four directions up, down, left, or right, but has the same value as the current cell. You cannot move to the cell that you visited in your last move. Okay, so one of my first questions is do you consider a grid as directed graph? Do you consider it to have like double-sided edges everywhere? Something, if anyone wants to talk about this in the comments, they are very welcome to do that. I'll just go ahead with this solution. A few things that I needed to keep in mind is connected components. It could be that some components are disconnected, and for that reason, you need to try out every single possible way. So you can't just start from A and like go everywhere, right? It could be that you missed out on some, you know, row column pairs or slash nodes, individual ones that um, you missed out on some cells in here because you were not trying out every cell. So you need to start the DFS from every cell and check if any of it returns a true or not, like every cell. That's important. And you check that cell if the parent of that cell is -1 comma -1, which means that this hasn't been visited. So initially initialize a parent array of the same size as this grid, n cross n dimensions, and pass that in with a path every time you start with a new DFS. Path is basically to keep track of what cells we have visited in the current path. In the DFS, we have the row, column, parent, and path. Add the row and column to your path now. And we have these difference of row and column numbers. So let's say we have this cell B, as you can see my cursor. So if you go up, you reduce the row by -1 and column stays the same. The next on the right, the row stays the same, but the column increases. Or below, if you go down, then the row increases by 1 and the column stays the same. And if you go left, then the row stays again the same, but the column decreases by 1. So that's all that I have captured here. Just to make it look a little prettier, also Striver did it to make code more readable and clean. So again, that's that. For k in range k, new row, you get the new rows time and new rows value, the new columns value, and now is where the real part comes in. Something that I use sometimes I actually get confused with this one. It's important to keep revising it so that you have your concepts clear. So if this new row is valid, there's a whole valid function for this. That is, the dimensions are inside the grid, and it has the same value, like the adjacent one has the same value as the current cell. Now, if the new row, so if the new cell in path, so if it was visited, like if it is already visited in this path, and this new row column, like let's say just write it like this, think, yeah, is not equal to, which means that this new row is not the parent. So it was already visited in this path, and this new row column is not the parent of row and column. It did not, like, it was not, like, it's not the parent of the row and column. That means that someone somewhere in this cycle visited it before. And that is where you understand that this is a cycle and you need to return true. I'll repeat again. So this new column exists in the path. It was already there in the path. And this new row, this new cell is not the parent of the current cell. So it did not come through this current cell, this row and column. It's come. So someone before visited this. So that's where you understand. Like you can draw like four cells and then like connect them and understand what I'm saying. But this is the important part. So if this new adjacent cell has been visited, and this adjacent cell that you're looking at, if it is not the parent of the current cell, then that means that there is a cycle and you need to return true. And if this next part is also very important. So if the new row is not in path, then it's not visited. You need to assign the parent of this new row and column as the current cell and perform a DFS on this new row, new column, parent and path. And if any of this returns true, you return it true. And after all of this is done, if nothing returns it true, then you just pop this row and column from the current path and return false. So that's it. Yep. Thank you.